So now we come to this recommender book slides, which are available freely online. I acknowledge them and give you the URL here. And this starts off with this basic problem of matching users with items. And obviously you do that to now enable the user to actually get some guidance, because the web has got so much information that the poor user usually needs guidance as to what to do. More generally, or actually more specifically, we're actually effectively offering assistance for sales. At least that's how it would be done at Amazon. If we were doing a job site, then it will be assistance in choosing jobs. And here it points out that a recommender system can be thought of as a software agent. An agent is just actually a piece of software that receives information and pops back out information. So an agent's a fancy term for most programs are agents. And this particular agent grabs the interest and the preferences of individual consumers and makes recommendations based on those interests and preferences. And we can see that this can be done in very different ways, which depend a lot on the particular problem to be solved, what data is available. We can use explicit data from the user feeds you information about what they like, or implicit information based on observing the user's behavior. And as it says here, these are very dependent on the particular domain, although there's some general principles which are discussed in these following slides, which cover different domains. So we've already mentioned some success criteria, namely money is often at some level the essential criteria. And I pointed out that in making some vendor happy by maximizing the money they get is not going to work unless you also maximize the user experience, whether it be their happiness or on something else. So these are rather nebulous concepts, which points out that these optimization problems are sort of heuristic. They're not, they don't have any very precise formulation. They can be formulated in many ways and solved in many ways. And they can be involve many different formulations. So in the case of information retrieval, we're trying to reduce the amount of searching needed and try to provide near the top of the list the pages that the user really might want. Usually in this case, the user has some idea what they're going on. If you look at some of these commerce sites, they often comment that a lot of their success is not in recommending actually what the user thinks they want, but pointing out to the user something they didn't know existed. That's sometimes called the long tail. So here we have a long tail slide, and here is a plot of popularity or knowledge of a product versus a list of products. And we have a few products, maybe 10 to 20%, which are very popular and generally well understood. And then we have hordes of products or books or what have you, where there's really very little knowledge, and it's pretty important to try to bring, if those are of interest to the user, to bring the right one to the user, because there's so many of them, you really have to be very precise. So here's some data here from movie recommendations from a site called Movie Lens, where it says that 74% of the positive ratings of movies are accumulated by 20% of the movies. So this is a standard 90-10, or in this case 80-20 rule. So the simplest way to formulate the optimization problem is to predict um, how much a user will like an item. That's a very common way of setting up the problem. More intuitively, we have to give the user a good feeling or educate them about this long tail and what to look for, and then maybe persuade or convince the user that we've got a good idea for them. And then this thing at the bottom comes back to this money again, namely for a website, what vendors who sell advertising want to do is to understand the conversion of an advertisement and the clicks on the advertisement to the users actually buying items. And that's called things like click-through and the difference between lookers who just browse and bookers who actually do things. So that can be a reasonably difficult optimization problem to formulate. So the simplest way to think about a recommender system is as a function which, given a model of the user and some items, it finds the relevance score or the relevance of the items to the user. And we've already mentioned that there is, as well as the commerce sites, these have clear relevance to information retrieval. And in fact, a lot of the success of Google is that PageRank provided a better recommending approach than previous methods, because it was more precise at giving back pages that were actually valuable to users. So here we have discussion of the different paradigms of recommender systems, and we will just go through them one at a time as they pop up on the screen here. And in general, all recommender systems are reducing the user's information overload by giving items different relevances and only presenting them, of course, the most relevant items. So the simplest thing to do is to get personalized recommendations. You have some information about the user, such as the rankings they did of previous products or the previous pages they searched. You use that to provide rankings of newer items, books, or pages, and that's a user profile based recommendation. Another type of data corresponds to community data. You use the information from a lot of users to give a recommendation for an individual user. Another important case is product features. You can try to match products to users by making a model of the product and what features it has, and try to provide to the user products which have the features they want. A good example of that is Pandora, the radio site, where Pandora actually uses information about the music on the site to give recommendations. It is, whereas other approaches, such as the Netflix one, tend to be more focused on not the community approach, where it looks at the rankings of other users to be able to decide which movies are most appropriate to recommend to you. It finds your community, the users that appear to have like things similar to you. Then it goes and sees what other things those users have looked at. So that was the previous community approach. And more abstractly, we can build a knowledge base and build a model for what's going on, and then try to find out, given that knowledge model, what I really want. And finally, we can put all of this stuff together and combine it to all four of these approaches to give what is in practice what, or more, in life, most things are not clean. you usually use some combination of many different approaches.